Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. I would like to say thank you for coming in my presentation. It's great to see you all. My name is Widodo. I will present about my paper about characterization of sensitive fiber with NaOH alkalization to increase tensile strength. The problem is how to characterize Sansevieria trifasciata fiber to obtain appropriate mechanical properties and chemical composition as a composite reinforcement material. How is the most optimal alkali treatment to get the best Sansevieria fiber properties for composite reinforcement? And next, how is the proper application of biocomposite produced from the use of Sansevieria fiber in the industry? Okay, the step of research, the first that we collect the Sansevieria plant and then we separate the fiber from the leaf of Sansevieria plant and then we make the composite that reinforce Sansevieria fiber. Then the goal of this research is to applicate this composite from many kind of part of vehicle, shipbuilding, prosthetic, socket prosthetic, and the other application. The specifications that Sansevieria fiber has great potential to be used as a composite reinforcement fiber. And then the Sansevieria fiber or the Sansevieria plant being biodegradable. So it's safe for the environment. And then Sansevieria is abundant in Southeast Asia, especially in Indonesia, and don't have commercial value. So we try to make it more have a high value of commercial. Then Sansevieria fiber has two main ingredients, cellulose and lignin. Cellulose has a role in giving strength properties to the fiber itself. Cellulose maintains the tensile strength of the material. To optimize the properties of cellulose, alkalization is carried out so that chemical changes occur that can improve its properties and characteristics. The method that we use, the first, we uh, conduct decortication to separate the fiber from the leaf of Sansevieria plant. And then the fiber, we conduct alkalization that use NaOH immersion or soaking with NOH. And then we analyze the characterization that occurs to get the best characteristic of Sansevieria fiber. The characteristic include chemical chain, cellulose and lignin. They can be changed because of alkalization process, and then the mechanic properties change. Yet that is tensile strength can improve with alkalization. This is the result we measure from FTIR test, Fourier transfer infrared test. The effect of alkaline treatment on sessile fibers structure. The graph shows the following characteristic. The position of the wavelength varies. The FTIR spectra of untreated and treated Sansevieria fiber with 5%, 10%, and 15% alkali concentration. These bands were reduced by the alkali treatment, indicating that NaOH NOH helps the elimination of hemicellulose. Similarly, the Swiss stretching vibration band that appears at 15-14 cm1 associated to lignin was also reduced after alkali treatment, demonstrating a partial removal of lignin. And then tensile test result that the test result of sensitive fiber with the treatment 5%, 10%, and 15% when at and when with NaOH treatment are shown in the graphs. At 15% concentration, the tensile strength becomes 3.52 Newton. So it is not possible to increase the alkali concentration again because it will further damage the cellulose content of the fiber. The increase in the value of the tensile strength at the concentration of 10% becomes a reference for the use of the composition of the NaOH solution in alkali. The conclusion of our research is the most effective NaOH concentration to remove lignin and increase the cellulose content was 10%. This is shown in the results of the fiber FTIR treatment with 10% NaOH alkali treatment giving the highest tensile strength. Okay, thank you. This is my presentation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.